Today we are going to discuss about the R to R ladder DAC. In last lecture we have discussed about the weighted resistor type method. In weighted resistor type method there are various types of resistors are used, and in R to R ladder method only two types of resistors are used. First one is 2R, another one is R. It is a combination of R to R resistor method. Here this is the circuit diagram of R to R ladder method. So this is a op-amp, and we are using in inverting mode. So this is B1, that is called as the MSB. This is B2, and this is the BN, and BN is LSB. Fine. So this is the circuit diagram of R to R ladder method. It only uses 2R in two types of resistor, 2R and R, in this type of combination. Now for understanding the working of this circuit, we will consider an example. That is the B1, B2, B3. Let us take example 100. B1 is 1, B2 is 0, and B3 is 0. Basically this circuit uses superposition theorem for calculating different values of for different input of different digital inputs. So here, this circuit would be redrawn like that. Okay, this is negative, this is positive, it is grounded, and here. So this is feedback resistor, that is the 2R, and this is the R resistor, and this is B1. Since B1 is 1, hence B1 is connected to minus VR. So here it is a resistor 2R, that is here 2R, and that is the 2R. It is connected to minus VR, and now this is R, and this is also R, and this is connected to 2R, and it is, since B2 is 0, hence this is ground, and this is again R, and B3 is also 0, hence it is also ground, 2R, and then final this type of 2R, it is also grounded. Now I will name the node. That is the node A, this is node B, this is node C, and this is suppose node D. Hence node A is at the ground value because because positive terminal is ground, and the value of positive terminal and negative terminal are equal. Since negative terminal is also at the virtual ground, hence the value of node A is 0. Now I will redraw the circuit here. So let us redraw. This is the B node, and it is connected to 2R, and it is minus VR. Now this is R, this is node A, and node A is connected to ground. This is node A, and this is connected to ground. Now node B, this is R, this is 2R, and it is connected to ground. This is R, this is R, this is node C. And look at here, these two resistors, R and these two resistors. Look at here. Okay. Look at here, these two resistors, 2R and 2R. These resistors are in parallel. Hence the value of this 2R becomes R. It is ground. Now these RR becomes are in series, and these RR becomes 2R, and again this 2R becomes parallel again. The final value becomes R. And let us redraw this. I will start from the node B. It is 2R, it is connected to minus VR. Here this is R, and this is node A, and node A is at ground value. Now this is node B. So this is R resistor, this, and this becomes R, this R, and this R. It is the ground. This is the node C. Now this can be redrawn in the final form like that. Here this is the B, it is connected to 2R. Let us see. I can explain it again, it is not visible here. So these two resistance RR becomes these two resistors are in series becomes 2R, and this 2R and this 2R are in parallel and becomes R again. So note C, this is R and this is R, this RR becomes 2R again, and these 2R I am writing here. This is minus VR, this is 2R, and this 2R is in ground form. No, this is R and this is the now these RR becomes, now this is the final. I am trying to redraw the circuit. Final, what becomes here, this is B, this is minus VR, this is 2R now, and here this two resistors, this R and this R are in parallel form, so here it becomes 2R by 3. Okay. Now what is the value of VB? VB equal to, using voltage dividing rule, it is 2R by 3 divided by 2R plus 2R by 3 into minus VR. Okay, fine. So the value of VB will be here 2R 6 to 8R by 3, यानी कि that becomes minus VR by 4. Minus VR by 4. This is the value of VB. Now the circuit finally redraws in the form of here. This is the V0 negative terminal. This is the positive terminal. Positive terminal is grounded. Negative terminal is connect. This is the feedback resistor 2R. Here this is the R resistor and this is the VB. That we have calculated. Now V0 equal to minus 2R by R into VB. Now V0 will be VR by 2. Fine. This is the value. Similarly, we can calculate for B1, B2, B3, that is the 0, 1, 0, and for B1, B2, B3, that is the 0, 0, 1. What are their values? Here, if we calculate here for this value, V0 will be VR by 4, and for this value V0 will be VR by 8. You can calculate it. This is your home assignment. You can calculate it. Now what will be, now using superposition theorem, what will be, we will use superposition theorem like that. So V0 equal to, what will be like that, VFS, and VFS B1 2 का power minus 1 plus B2 2 का power minus 2 plus B3 2 का power minus 3, like that. When look at there, when B2 is 0, B3 is 0, V0 equal to VFS by 2. When B1 is 0, B2 is 1, B3 is 0, V0 equal to VFS by 4. V0 when B1 equal to 0, B2 equal to 0, B3 equal to 1, then V0 will be equal to VFS by 8. So using, I have only added these values and I got the output, that is using superposition theorem. Now you can draw the same as the chart and look at this expression. This expression is same as that we have got in initial classes, in the initial class, that is for DAC converter. So you can draw the chart here like that. B1, B2, B3, and here the output. It is here V0. 0 0 0, V0 will be 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0, and then finally 1 1 1. We can calculate it. For here what we'll get? VR by 8. I will only write that here. For here I will get VR by 4, and this for VR by 2. So you can calculate all this, complete this table. Now there are few terms related here. First let us discuss these terms. First one is called as the specification of DAC. Specification of DAC. So what was the specification? First one, these terms are called as a specification. Resolution. Number 2 is called as linearity. Number 3 is accuracy. Another one is called as the temperature sensitivity. Temperature sensitivity. Another one is settling time. And next one is speed. So any DAC should have this type of features or specifications. What is resolution? Resolution formula is VFS divided by 2 ka power n minus 1. Yeah, percentage resolution. This is called as resolution, or it is called as also as a step size. It means that if you have seen that for every digital input there is corresponding analog input, and digital input are not continuous, it is in a step form. So for one step there is corresponding analog output, another step there is a corresponding analog output. So resolution or step size is for any input of digital, the output of analog we are getting. That is called as the resolution. Linearity means that the graph should be linear. It should be not like zigzag or exponential. Graph should be linear. Accuracy, the output value should be accurate. It does not have a much more variation. And temperature sensitivity, this DAC should be temperature constant. It means that as the change in temperature, the output does not changes much. There will be small changes, but changes should be not be large. Settling time, that means the time required for getting output, that is called the settling time. If we give in input, after how much time we are getting output. So this is called the settling time. DAC should have a very good settling time, high settling time. That means after giving input, the output should be in almost in nanosecond meter. Speed, that is the same as time required by a DAC to convert one input into output, that is called as the speed. It should be fast. So these are the few specifications, these are the resolutions. Now we will see some problem regarding that. I think in the next class we will see some problem of DAC. Okay, thank you.